I appreciate everybody coming today. It's definitely a privilege to speak at the first of anything. So the first Operational Excellence Conference here. Really appreciate being invited and to speak at it. We'll be talking a little bit about alarm management meets SIS. And I do want to give proper credit to the engineer that came up with this. A gentleman by the name of Darwin Logerow. He is one of our engineers that is a voting member on the IS 18.2 committee, and as we were going through a number of projects, he was like noticing this thing called SIS that was causing us a lot of issues in alarm management. And so we wanted to talk a little bit about, give some real practical suggestions as to that. And if you guys have the slideshow, it's a pretty good thing to take into your alarm philosophy reviews or your alarm rationalization reviews. You can really take and utilize some of the information. In here, we actually give this presentation a lot when we are doing our initial alarm management training at a given site. So why are we here presenting? What is ProSys? We're a professional engineering firm. We have offices here in Houston as well as in Baton Rouge, and we have office in Germany as well. We're most known for alarm management. We've been doing that since about 1991. So before the advent of SIS, so when that came across, we started seeing some changes there, and that's what sort of propagated this presentation. We do a lot of operator interface, a lot of advanced operator displays, situational awareness, that type of thing, on operational displays, boundary management, or some people call that ops limits. That's another area that's been growing and expanding there. Basic control, advanced control and optimization, a lot of MPC implementations we do as well. So you can see some of those things. State-based control is another area that's growing, or it's more popularly known as procedural automation, dynamic simulation, and control system ISP support. A lot of people put these in a bucket and they call that advanced apps, basically, is what we offer. Anything that sits on top of the control system that leverages it is largely what we're doing. So some of the presentation goals. As a good engineer, I have to define the terms I'm going to use, right? Because we don't like to miscommunicate. We're all into the details about that. So I'll go ahead and do that. We'll talk a little bit about the basic functionality and why that causes alarms there with the SIS, and some of the alarm management basics, and then we'll take you into some real practical details, some requirements, some different things that we're going to recommend that you should do with your SIS system as it relates to alarming there. So right on to the definitions. An alarm, there's a definition in ISA 18.2 about this. It's an audible or visible means of indicating the operator equipment malfunction, process deviation, abnormal condition, right? So it's something that indicates something's bad going to happen, right? We're trying to notify the operator, hey, this thing that's going to happen, here's the alarm, you can react to it and potentially limit the consequence or prevent the consequence from occurring. So alarms, one thing to keep in mind, are all about consequences. No consequence, no alarm, right? Consequence, alarm, right? So that's one of the important things. Basic Process Control System, BPCS, that is our control system there that's responding to the inputs. It's not part of the safety integrated system. The instrumented system is part of the basic control of the process, right? So that's one of the elements that's there, and that's defined in ISA 84. Safety instrument system, that's very well defined in ISA 84, right? So you have that there. That is our system that's performing our SIS, right? It's the thing that we're implementing these recommendations in, that you guys saw earlier how to do a well design on that. But that's our safety instrumented system that's out there. It's our Triconics, it's our safety manager, whatever system you're using there, that is the system that's implemented. A SIF obviously is a function that we're trying to protect against. And again, those are well defined in ISA 84. Independent protection layer, this is something that's been discussed, but basically the understanding of that is that this is something that would protect the process from going into one of these bad areas where we'd have consequences occurring. So where we're at, we're trying to define as many layers between us and this bad thing happening. And so they have to be independent, which is part of the definition. I can't have one failure lead to the failure of multiple of these layers. And that is defined in AIC Chief. So this is from my 10-year-old daughter. IMHO stands for in my humble opinion. She had a whole lot of acronyms for my presentation. I just put that one in. But if you guys want that presentation, you can get with me afterwards on that. So I used IMHO in this presentation, and so I needed to define it. So SIS basics. So the SIS, you guys know this already, but basically it's designed to take an automated action, right? We're sitting there, we're running along, a condition occurs, we detect the SIS, detects the condition, it takes corrective action to put the process into a predefined state, a normal operating state that we want it in, right, in response to that condition, right? To prevent what? Unwanted states, right? We say this area is bad, this area is good, and if I start to go that way, at some point we say, okay, we're going to go this direction with it instead of continuing in that direction, right? So we're trying to bring the plant to a safe state in the event of this process excursion. So I'm running here, and for some reason I start heading in a wrong direction. And at some point we say, hey, that's enough. We need to cut it out. We need to go in a different direction. It's independent of the process control system, right? The process control system could be an initiator of it, right? It could be dragging us in that direction. It's got to be independent of other IPLs, right? So I can't have hardware systems or anything else that's there. It's got to be all independent there. It can be composed of multiple safety instrument functions. So I put a whole lot of different functions into a single SIS there. And obviously each SIF can have different sensors. And so this is sort of where the challenge starts to begin now, right? Because when in a control system, when we have inputs or sensors, we like to put alarms on them, right? And we got outputs, we like to do different things there too. We can even alarm those, believe it or not. And so there becomes a lot of opportunity, and a lot of people get creative and say, oh, I can alarm this or I can alarm that. That might tell me some information I might want to know, right? And notice the verbiage I'm using there, right? And so we're going to start going through that. And so one of the things that we noticed is that there were two really bad actors when we started measuring like alarms back in the mid-90s, late 90s. We started looking at this stuff, and we noticed that there's one particular area was growing, and it was alarms coming from our SIS systems that we were enunciating in the control system. And it actually started eclipsing all other areas as being the worst actor there. The two areas were bad instrumentation alarms, right? Instrumentation alarms like foundation fill bus, those type things. And the other one was the SIS. And so eventually we got to where a majority of alarm floods were actually caused by SIS systems. And we said, wait a minute, we need to take a look at this. And there was a lot of misconceptions out there in industry, and that's what you're going to see, so we're going to talk about this. So SIS basics, right? An operator action is not required for my SIS to operate correctly. Is that correct? Yes. Everybody can say yes to that one, right? If I required my operator for my SIS to function, that's not a good thing, right? It's not independent. So there's nothing there that SIS needs from the operator in order for it to run correctly. And that's an important thing when we start talking about alarms, right? So operator actions, right? So that alarm is doing what? It's asking the operator to act, right? So now you can sort of see a little bit where I'm going with this first point. So operator actions, there are some things that he can do, right? So I might be heading in this direction towards my bad area that's over here, and as I get it so far down that road, I'm going to go, well, if I get to here, I'm going to this other area, and I don't necessarily want that to occur. I would like to go back to where I came from, right? So that would be one thing. So I can prevent this SIS trip before the fact. That's one of the things that can occur there. Because there is consequences of that SIS trip occurring. What are some of the consequences? Anybody? Loss of productivity, right? Right, you got to answer a little bit to the shareholders as why we're not making as much product right now. There are issues, and to be truthful, it's not 100% as well. That's the other thing that people would get into an issue with SIS is that people think, well, it's bulletproof. Well, I don't want to constantly be hitting that. You have a demand calculation there, right? And if I'm currently, it's like me driving my car down the road. If I'm sitting here, I'm going to drive back to Baton Rouge this afternoon. I could say, you know what? I'm just going to put the right fender right up on that guardrail. I'm just going to ride it all the way to Baton Rouge. Would that be a good plan? No, but if I'm sitting there tripping on my SIS system all the time, that's basically the way I'm running my plant. So you got to be careful about how you do that. So that's one of the things why we might have alarms between us and more our SIS trips, because we want to prevent activations of that SIS, because then it drives my demand calculation in the wrong direction. So troubleshoot. Why did the SIF trip? Why did we end up in the situation that we're in? That is another thing. We'll talk a little bit about that. To secure the remainder of the plant, right? If I have one unit that trips out, I might very well need to take operations in other places. I might need to limit feed coming to that unit. I might need to divert things to different areas. And so those are some of the things that can happen. In truth, if you look in plants, bad things happen because we have energy or material going to places we don't expect them, right? That in the big picture, that's what we're trying to do. We're trying to control the flow of energy and material in our plant. And so if we keep them all in the right buckets, we do good, right? If we get things messed up, then we end up with material either leaving the process or getting mixed in a way that can cause an excursion, we're in big trouble, right? So that's one of the challenges. And the SIS is isolating that at a point, but what happens to everything outside that boundary? That can very much cause the operator a lot of work. Obviously, restart, that's the first thing when you trip. What are you looking to do? Hey, we got to get it running again.